If I consider hexadecimal number, what is the value for C? It is 12. If I want to convert octal number to hexadecimal number, I am going to take the help of binary number system. After writing binary equivalent, what I am going to do? I am going to use the method called binary to decimal conversion. Hello to all, a warm welcome to my new session on data representation. I am Revati, faculty, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. Before going to start my today's session, let me to recall the things what we discussed in my previous session. In my previous session, we discussed how to convert decimal number to hexadecimal numbers and what are the rules I want to follow while converting. Then we had discussion regarding how to convert hexadecimal numbers to decimal numbers and what are the rules I need to follow while converting. Then we had discussion regarding binary number to octal number. There we discussed how to convert the binary number to octal number along with the rules. Then we had discussion regarding how to convert octal number to binary number and binary number to hexadecimal number. Along with the rules, we solved some of the example problem. But in my today's session, I'm going to discuss hexadecimal numbers to binary number. That means how can I convert my hexadecimal number to binary number and what are the rules I need to follow while converting. Then once again, I am going to discuss octal number to hexadecimal number. That means how can I convert the octal number to hexadecimal number and what are the rules and steps I need to follow while converting octal number to hexadecimal number along with the example. Then we are going to discuss hexadecimal number to octal number along with the steps, along with the example. Then we are going to have the discussion regarding what is binary arithmetic, why we required binary arithmetic. Along with we are going to study binary addition with example. Instead of wasting much of time, directly moving on to the topic that is binary number. That means how can I convert the hexadecimal number to binary and what are the steps I need to follow while converting hexadecimal number to binary. So what is the first step I'm going to have? That is take individual digit. That means during conversion, I want to consider individual digit from hexadecimal number. That means whatever the given number we are going to have that is in the form of hexadecimal, from that I want to consider individual digit at a time. Then convert each digit into 4-bit binary number. Now what I want to do, I am going to write the binary equivalent for each digit, that is 4-bit binary equivalent, and at the end I am going to club all the bits together in order to find the final solution, and whatever the final solution I'm going to get, that's in the form of binary numbers. Now consider the example here. So what's the example I have? That is CEBA. If I consider hexadecimal number, what is the value for C? It is 12. Then what's the value for E? It is 14. And if I consider B, what's the value? It is 11. And if I consider A, and what's the value I'm having? It is 10. So according to the rule, what I want to do? I want to separate the digit individually. And for individual digit, I'm going to write the 4-bit binary representation. Now, how can I write 12? That is 12 divided by 2. 2 6 are 0 remainder, 2 3s are 0, then 2 1s are 1 remainder. Then what's the value? It is 1 1 0 1. Similarly, I'm going to find the binary value for 14. I'm going to find the binary value for 11 and binary representation of 10, and I'm going to club all the values together. How I'm going to club? I'm going to start from top and I'm going to move towards down. So I'll write 1 1 0 0 first, then I'll write 1 1 0, then I'll write 0 1 1 1, then I'll write 1 0 1 0, and it's of binary. So this is the way I can able to convert the hexadecimal number to binary. This is the way I can able to convert hexadecimal to binary. Now consider another example. Think that I'm going to have 6 3 4. Now according to the rule, what I want to do, I want to consider individual digit at a time. So I'll write 6 3 and 4. Now I'm going to write the binary representation for individual digit, and it must include 4-bit. So I'll write 0 0 0 1 1 and 0 1 0 0. And while writing final result, 6 3 4 of 16 equal to 0 1 1 0 0 1 1 0 1 0 0 of 2. This is the another example. Moving further, I'm going to have conversion, that is how can I convert octal number to hexadecimal number, and what are the rules I need to follow here. At the beginning, using binary number system, we can easily convert octal number to hexadecimal number. That means if I want to convert octal number to hexadecimal number, I'm going to take the help of binary number system. That means I'm going to use binary number system as my intermediator. Now, what is my first step? Write the binary equivalent of each octal digit. That means whatever the octal number I'm going to have, I'm going to consider individual bit at a time, and I'm going to write the binary equivalent of the individual digit. And in my step 2, I'm going to regroup them into 4 bits. That means at the beginning, to write binary numbers, I'm going to consider 3-bit because it is octal number. But to convert octal to hexadecimal, I'm going to make a pair of 4 bits together. So regroup them into 4 bits from the right side with zeros added if necessary. That means if I want to make a group of 4 bits, if it is necessary, I can able to add 0 at the end. In my step 3, convert each group into its equivalent hexadecimal number. After making group, what I want to do? I want to convert each group into its hexadecimal equivalent value. Let's consider the example here. I have 274. So this is my octal number. To represent octal to hexadecimal, or to convert octal to hexadecimal number, I'm going to use binary number system. First, I'm going to consider the individual bit from the octal number. and for that number, I'm going to write the binary equivalent. So at the beginning, I'm having 2. Now I'm going to write the binary number. Now I'm going to write the binary number. Now I'm going to consider second digit. For that, once again, I'll write the binary number. And here I'm going to consider 4. For 4, I'm going to write the binary representation. And I'm going to write the binary number from top to bottom. And while making group, I want to consider 4 bit. So I'll consider 1100 is my first group, and this is my second group, and this is my third group. Now I'm going to write the hexadecimal equivalent. So it is 12. 12 is nothing but C, and it is 11. 11 is nothing but B, and 0 I'm going to represent as it is. So what is the hexadecimal equivalent for the octal number 274? It is BC. Here BC. So that is nothing but 11 and 12. So I'm going to represent 11 and 12 in the form of B and C. Then I'm going to have, that is, conversion from hexadecimal number to octal number. That means whatever the example I'm having, that is in the form of hexadecimal number, and I want to convert that number into octal number. For that, what are the rules I need to follow? That is, step 1, write the binary equivalent. First, I want to consider individual digit from the hexadecimal number. For that, I'm going to write the binary equivalent. Then, I'm going to regroup the bit. That is, to make a octal number, I'm going to pair a group. Each pair includes 3 bits, and convert each group into its equivalent octal number. Now what I want to do? I want to convert that group into octal number. So what are the procedure I need to follow? First, I want to consider individual digit from the hexadecimal number, and I'm going to write the binary representation. And while grouping, I'm going to consider 3 bit together, and I'm going to write the octal equivalent for that binary 3 bit of data. Now consider the example here. It is FADE. That is 15, 10, 13 and 14. Now I want to write the binary numbers. For 15, it is 4, 1. For A, that's nothing but 10, it is 1, 0, 1, 0. And for D, it is 13, and what's the binary representation? That is 1, 1, 0, 1. And for E, it is 14, and what's the binary equivalent? That is nothing but 1, 1, 1, 0. Now, I'm going to write the output. To write the output, I'm going to consider the topmost digit first, and I'm going to move towards down. Now, this is my binary representation. Now, I want to convert this binary number to octal. For that, what I will do? I'm going to make a pair of 3 bits. So, I will make a 3 bit. That means I'm going to consider 3 bit. Now, I'm going to write the octal equivalent. So, it is 6, it is 3, it is 3, it is 5, and it is 7, and it is 1. Now, I'm going to club all this bit together in order to get my octal result. So, what is my hexadecimal number? It is FADE. And what is my octal value? That's nothing but 175336, and it is my octal number. Then I'm going to have the shortcut, that is shortcut method to convert hexadecimal to decimal number. That means I'm using shortcut. I'm going to convert the hexadecimal number to decimal number. So at the beginning, I'm going to have the hexadecimal number, that is 5F. Now what I will do? I'm going to write the binary equivalent. That is, F is nothing but 4, 1 and 5 is nothing but 0, 1, 0. Now I'm going to consider all the bits together. I'll start writing 0, 1, 0, 1, 1, 1, 1, 1. Now I'm going to write the binary to hexadecimal conversion. That is 1, that is 0 into 2 to the power 1, 2, 3, 4, 5, 6, 7, 8. So I'll write 7 plus 1 into 2 to the power 6 plus 0 into 2 to the power 5 plus 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Now, if I consider 2 to the power 0 is 1. 1 into 1, I'm going to have 1 plus 2 to the power 1, it is 2. 2 into 1, it is 2. Then I'm going to have 2 to the power 2. That is nothing but 4. 4 into 1, it is 4. Plus 2 to the power 3, it is nothing but 8. 8 into 1, it is 8. Plus, then I'm going to have 2 to the power 4. That is nothing but 16. 2 to the power 16, how much? It is 2 to the power is nothing but 16. 16 into 1, it is 16. Plus 2 to the power 5, it is 0. That is 2 to the power 5 is 35 into 0, it is 0. 2 to the power 6, it is 64 into 1, it is 64. Now I add all this number together, I'm going to get 95. This is the way I can able to convert the hexadecimal number to decimal number. How I'm going to convert? First, I'm going to write the binary equivalent. After writing binary equivalent, what I'm going to do? I'm going to use the method called binary to decimal conversion. After that, I'm going to get the decimal number. This is my final solution. This is the way I can able to convert hexadecimal number to decimal number. Moving further, I'm going to have binary arithmetic. If I consider digit, in digit I can able to perform different kinds of arithmetic operation. Similarly, if I use binary, then by using binary numbers, I can able to perform certain arithmetic operations. What are the arithmetic operations I can able to perform here? That is nothing but addition, subtraction, multiplication and division. So here binary arithmetic is much simpler to learn because system deals with only 2 digits, zeros and ones. Here binary arithmetic is very simple and very easy to learn because here we are going to have only 2 possibilities, that is zeros and ones. When binary arithmetic operations are performed on binary numbers, the result is also in the form of zeros as well as ones. That means when we perform any binary arithmetic on binary numbers, what are the output we are going to get? That is in the form of zeros and ones. Now I'm going to have the binary addition. To perform binary addition, what are the rules I need to follow? Let's see one by one. The addition of two binary number is performed in same manner as the addition of decimal. That means how we can able to perform addition of decimal numbers. Similarly, we can able to perform the addition of binary numbers. It adds only 2 digits. But using binary addition, we can able to add only 2 bits and gives sum and carry. That means here we can able to add only 2 bits. After adding 2 bits, I can able to get sum or carry. If any carry is generated, that is carried over to the next bit. To perform binary addition, we must consider this table. According to the rule, I am going to have only 2 bits, that is A and B. And I am going to write the possible input. So it is my 0, 1, 2 and 3. And this is my decimal representation. And I am going to represent 0 in the form of 0, 0, 1 is nothing but 0, 1, 2 is nothing but 1, 0 and 3 is nothing but 1 and 1. Now I am going to apply the addition operation. So at the beginning I am going to have 0 and here I am going to have 0. When I add 0 with 0, I am going to get the sum 0 and I am going to get the carry 0. If I take another bit, that is 0 plus 1, I am going to get the sum 1 and carry 0. And if I consider third value, here I am having 1 plus 0, it is sum is 1 and carry is 0. And if I consider last one, I am having both the ones. When I add 1 plus 1, I am going to get the sum 0 and I am going to get the carry 1. So this is the way I can able to add 2 bits. And while adding, I want to consider this table. Now consider the example here, that is I am going to have 4 and 3. That means I want to add 4 plus 3. What is the result? It is 7. So first what I want to do, I want to write the binary equivalent. This is my decimal number and I am going to write the binary equivalent. After converting decimal to binary, I am having 100 plus 011. Now I am going to perform addition operation. So I am going to write the operator called plus. So I will add 1 plus 0, I am going to get 1. 1 plus 0, I am going to get 1 and 1 plus 0, I am going to get 1. This is the way I can able to add 2 numbers. Now consider another example here. So I am having decimal number 5 and 9. So at the beginning I am having 9 and I am having 5. 9 plus 5, it is 14. Now I am going to write the binary equivalent. Now I am going to perform the addition operation. That is 1 plus 1, sum is 0 and 1 carry. Now 0 plus 0, it is 0. 0 plus 1, it is 1. Now 1 plus 0, it is 1. Here 1. So 1, 1, 1, 0. That is nothing but 14. This is the way I can able to perform the addition of a given binary number. Now I'm going to consider another example, that is nothing but 75 and 18. First, I want to write the binary representation of 17 as well as 18. Now, I'm going to write the binary representation of 75 as well as 18, and I'm going to perform the addition. So, here I'm going to have 0 and 1. That is 0 plus 1, it is 1. Now, if I consider second bit, I'm going to have 1 and 1. 1 plus 1, that is 1 is carry and 0 is my sum. That means I'm going to write the sum, that is 0, and I'm going to carry 1. Now, here I have 0. 0 plus 0, it is 0, but I'm having 1 carry. That is 0 plus 1, it is 1. Now, here I'm having 1 plus 0. That is 1 plus 0, it is 1. Now, here I'm having 0 plus 1, it is 1. So, I'll get the 0 as it is. I'll write the 1 as it is. This is the way I can able to perform binary addition. Moving further, I'm going to consider another example. Here, I'm going to have the integral part as well as fractional part. Now, I'm going to write the binary numbers as it is, and I'm going to perform addition operation. So, here I have 1 and 1. That is nothing but 1 plus 1, it is 0. That is 0 is sum and 1 is carry. Now, 1 plus 1, it is 0. 0 is sum and 1 is carry. Now, I am going to add this 0 with 1, that is 0 plus 1, it is 1. So, I will write 1. Now, here I am having 1 plus 0, it is 1. I am going to consider this carry 1, that is 1 plus 1. I am going to get the sum 0, 1, carry. Now, here I am going to have 1 plus 1. So, 1 plus 1 in the sense I am going to get sum 0 and 1 carry. So, here I have 0, 0 plus carry 1, it is 1. Now, here 0 plus 1, it is 1. 1 plus carry, it is 0 and 1 carry. Now, I am going to consider this. So, 1 plus 0, it is 1. 1 plus 1, it is 1, 0. So, 0 is my sum and 1 is my carry. Now, I have 1 plus 1, that is 0, 1, 0 and 1. But here I have 1 carry. That is 0 plus 1, it is 1. I am going to write the carry as it is. Dear student, this is the way I can able to perform the addition of fractional values. So, dear student, in my today's session, we studied how to perform the binary addition. What are the rules we want to follow while performing addition operation. Along with, we discussed some of the conversion methods. I hope, dear student, in my today's session, you got more information about the data representation. Let's meet in the next session with more information about the data representation. Until then, keep watching and keep learning. Thank you.